Gabriel René. He is the founder and CEO of Versus Technologies, a company at the forefront of AI and spatial computing. With over 25 years of experience, Gabriel's work integrates AI, IoT, and XR to build immersive digital environments. His vision explores the potential of AI-driven hyperintelligence for global innovation. So he will have an interesting presentation about called Beyond Superintelligence, a natural path to planet scale hyperintelligence. Welcome, Gabriel. Thank you for joining us.
Thank you for having me. I really I'm grateful for the opportunity to share with everyone today. Can you guys see my screen all right?
Yes, we can see it.
Okay, let me get started. Forgive me if I go a bit fast, and it's a lot to digest, but I'm happy to answer any questions afterwards. So the human species has a very unique gift. We learn not just through what's been encoded in genetic memory, but by what we pass along mimetically, and in words and images and art, and through our tools. We build generation upon generation. We compound our knowledge, our skills, our learning, our intelligence. But it's our inventive spirit, our imagination, that's our greatest superpower. Each generation, when faced with a new set of challenges, we've imagined and then invented a new set of tools. And these tools reshaped our society, in each case, for the better, in most cases, we hope. And that therein lies the challenge around, I think, AI and governance. But this is who we are. We're tool makers, we're creators, we're Imagineers. We invent tools as a form of creative adaptation. It's how we evolve. It's through intention and invention. We build these tools to extend ourselves, extend our reach beyond our biological limitations. So from spears to wheels to rockets, to have the ability to reach further and go farther. We've extended our bodies this way. We've extended our senses through things like the telephone and the television and the telescope, so that we can see and hear and speak to each other across space and time, like we are right now. And we've expanded our knowledge, our memory, from cave paintings to the shelves of the great libraries to the collective memory of humanity traveling down the digital threads of the web. And it's this ability to imagine different outcomes and better futures that has enabled us to extend our reach through the power of these tools. And technology has led to rapid growth, progress, and for many of us, abundance, privilege that some of us enjoy today, but certainly not everybody. But this inability to imagine the side effects of our technologies has led us to here. Short-sightedness, one-size-fits-all solutions, infinite growth at any cost. Other industrial byproducts have ushered in an era of compounding disasters, what I call a hypercrisis, a combination of economic, ecological, political, and societal challenges that have become too complex and too interdependent and interwoven for us to solve. So we have this innate ability to imagine new tools, new technologies, but we struggle to imagine their long-term effects. And so once again, we find ourselves at the limits of our biological limitations. We simply aren't smart enough to solve the problems we face at the scale and speed that they're occurring. We need more intelligence. We've hit an intelligence ceiling. Just like when we couldn't reach far enough to get the rabbit, we had to invent some new kind of tool to extend that reach. We have now hit our cognitive limits. In the last decade, AI has, emerged, deep learning and generative models, as a pursuit to exceed the intelligence ceiling, right? And pursuing this notion of a super intelligent AI that's millions of times smarter than humans. And it's driven by this sort of religious fanaticism around this idea of scale is all you need. More data, more compute, more energy. And in spite of all this information on the web and the more power than any system we've ever developed, these systems are still extremely error prone. They're static, they're black boxes, they're unexplainable. This kind of blind arms race to chase superintelligence also ignores the broader social impacts and ethical considerations I'm sure many of the speakers have been talking about in the last couple of days, all while being extremely, almost comically energy and resource intensive. I mean, just this month, we've seen multiple references from moving from $1 billion to $100 billion data centers, right? And the amount of compute that's needed for these systems, the amount of energy that's needed for these systems. And we're restarting 3 Mile Island and nuclear plants and global partnerships to access gigawatts of energy. But there's something really wrong here. Your brain uses 20 watts, right, to do some really amazing things. So why do we think a massive energy consuming machine is the best way to enable the kind of intelligence we need to solve the problems we can't solve on our own? It's a story. It's a machine myth, a vision of the world born out of the industrial age. AI is not some magical new technology. It's the product of industrial era thinking. The industrial mindset trying to produce a massive industrial scale mind inside a machine. This is very similar to what we did in the 70s. A supercomputer. Let's build one computer, everyone will attach to it. Personal computing microprocessors come along. No, everyone gets their own computer. This idea of a big factory powered by a nuclear plant with a bunch of computer chips is just the same idea we've been running here for a couple hundred years. And this myth is psychological. It tells us that everything is a machine, and that as a result, we design all of our technological and societal systems to work like a machine. Our education system is a machine. Our economy is a machine. Our political process is a machine. Our entire society runs like a machine. Not a very good machine, by the way, and one that increasingly appears to be breaking at the edges. So, of course, we think the mind is a machine, and that it would process information like a machine. We actually can't even think of our brains as something other than machine. And so therefore, we believe that we are machines. We can't help but believe this myth, right? But deep down, you can feel it. Something about this feels very wrong because we aren't machines. We're much more than machines. Neuroscience has shown that intelligence is not a machine process. It's not deterministic. It's not random. It's ordered. It's structured. It's adaptive. Right? Intelligence is the ability to adapt to change, not black box static industrial scale models that cannot learn by themselves or adapt. Intelligence is adapting to change, constant change. But the high priests of artificial intelligence industry proclaim that the machine myth is our destiny, right? It's coming. The machine superintelligence is going to be our salvation. It's going to be smart enough to solve all of our problems. And that the machine age, as foretold in all of our sci-fi stories, is finally coming. But what if I told you that we're not at the beginning of the machine age, but we're rather at the end? An age that began with machine printing is ending with machines learning, right? What we really need to solve this hyper crisis and to explore the opportunities that lie beyond the intelligence ceiling is a higher order of intelligence, not machine intelligence, right? To enable this kind of intelligence, we must transcend the machine myth and the notion that a machine is going to be a salvation, as well as move beyond the limitations of our own biology. And the blueprint for this kind of intelligence cannot be found in a machine. We have to look to the source of intelligence. We have to look to nature. It shouldn't come as a surprise that nature holds the blueprint for true intelligence. I mean, intelligence isn't artificial. It's natural. It's a natural process. It exists all around us, right? Right in front of us. It in fact is us. We're not machines. We are nature. And intelligence is not the product of a random or rigid machine process, but of systems that are adaptive, embodied, distributed, and efficient. Intelligence enables continual learning, flowing like a river. It's organisms that change with their environments and that change their environments. We're interconnected. We're interdependent. It's not just in us. Intelligence is not limited to human intelligence, right? Intelligence shows up in bacteria, in the bodies of blue whales, and the cooperative behavior of cells in your body, and the networks of mycelium connected forests, growing, adapting, learning together. It's alive, right? Intelligence is hyper efficient. You use 20 watts. It requires very little energy. This is a function of physics, of thermodynamics. You don't get all the time in the world to make a decision, and you don't have all the data in the world. You don't have all the compute. So the algorithm of intelligence has to basically be able to work very quickly, very smart, very, very small. This is by design, right? Evolution has selected for an algorithm that can imagine actions before taking it. That turns out that's the secret sauce. Nature prefers imagination or simulation to trial and error because trial is expensive and error is, potentially fatal. But perhaps the most amazing feature of natural intelligence is that it does not seek to dominate. It seeks to balance. and coexist. We talk about governance or alignment or regulation. Well, these are self-regulating systems, right? It does this through collective dance that occurs at all scales of life, right? This dance occurs within us. Right? We self-regulate. Our body temperature, for example, is regulated by a complex systems of cells and tissues and organs, all working together to maintain homeostasis, to keep you aligned. Right? This alignment is by design. It's not alignment after the fact, where each individual must model and align with its environment and realign as it changes. That's adaptation. Our industrial style tools, including today's AI models, are simply too crude to enable this process. They don't adapt, so they can't align, because what you need to align with constantly changes. So if artificial intelligence and super intelligent agent is not the goal, then what is? Maybe we're thinking about intelligence all wrong. Like, intelligence is not a monolith, right? It comes in all forms rather than a one-size-fits-all supermodel. It's diverse, it's specialized. Octopus intelligence is different than bat intelligence, is different than human intelligence, and intelligence is happening at all scales, right? It requires cooperation, collaboration. Higher forms of intelligence result from smaller forms of intelligence working together at different scales. And we see this in cells, organisms of the world that organize into communities like this community, right? We're smarter together, collaborating at higher orders of intelligence, just like swarms of ants and flocks of birds and schools of fish. Right? Natural intelligence is collective intelligence, right? Not a single intelligence. The question is, can natural intelligence be encoded into software? Can we use this to drive machine capabilities? But that also extends our, human biological intelligent capabilities. The answer is yes, right? Intelligence has already made the leap, different formats, right? It's demonstrated its ability to be encoded, RNA, DNA, neurons, so on. Our research teams at Versus, which were led by world-renowned neuroscientist Carl Friston, have decoded the algorithm of intelligence and granted us the ability to translate this process of natural adaptive intelligence into software. With this algorithm, we're developing a new kind of software that can autonomously learn and adapt like biological intelligence. This enables it to become significantly smarter, safer, and more sustainable than current AI systems or approaches. Last year, on August 7th, we published a peer-reviewed paper in Nature Communications announcing that researchers from Japan and working with our teams here successfully demonstrated the self-organization process of neurons in the brain, essentially how neurons learn. That's based on the mathematical models of Carl Friston, known as the free energy principle, and its application known as active inference, the ability to constantly infer actively and update your model in real time. And so active inference is a theoretical mathematical framework which suggests that the brain is constantly making predictions about the world and then correcting those predictions based on sensory input. The opposite of a machine process where inputs come in, you process, and an output. Turns out the brain is actively participating in projecting its imagination into the world and using its sensory information to measure the difference. It's based on the idea that our brains are prediction engines, right? Always trying to minimize the difference between what we expect and what actually happens. This research demonstrated in the Nature Communications paper that the active inference is the self-organizing principle of biological neural networks. And that can also be used to create next generation artificial intelligence that learns as living neural networks do. So our team of engineers and computational neuroscientists at Versus have been developing this new class of intelligent software. And the latest research that we have, and we're happy to share any of this with you guys, has demonstrated unprecedented gains over traditional AI that operate with a fraction of the data, a fraction of the energetic costs of current approaches, that can self-correct and self-adapt in real time. Right? By following the blueprint of nature, we believe that we have a path to truly intelligent software that's based on natural intelligence, a new kind of tool, right? Not artificial intelligence, but natural computing. And we believe that the path to enable truly intelligent software to be based on natural intelligence, that this is technology powered by nature. So to conclude here, imagine a tool with the modeling and processing capabilities of multiple agents, right, working together to track and model the complexities of the whole planet in real time, projecting years, even decades into the future, because essentially these are prediction machines. It's not just about imagining though and simulating and predicting. It's a tool that can enable us to automate and create a better world. So we can make more informed decisions and take intelligent actions that drive growth while ensuring a dynamic balance homeostatically, sort of an autonomic nervous system for the planet at global scale. When we created the combustion engine, we imagined a new form of mobility, but we were unable to predict the impact that it would have on the climate. I mean, we can avoid these kinds of mistakes if we have a new kind of tool that aligns with the fundamentals of nature, that aligns with us and helps us design and implement truly sustainable societal systems. Technology, it's not just about making, phones smart or cars smart, but make everything smarter: people, places, things, cities, and not through artificial mechanisms, but really through an understanding of how to extend natural systems. We call these tools agents, right? They're not merely machines. They operate on the same probabilistic algorithms that biological intelligence uses, which is what enables them to adapt and learn by themselves. So they're capable of autonomous decision-making and action. They're capable of learning from the data and operating in any environment. This is from software that runs on your computer or your phone or a camera to robots, drones, the whole thing, right? Just like your neurons are able to encode every sort of sensory input in multimodality, they're capable of doing this. Now, because of the way they're being designed, we can trust them to operate autonomously in both real and digital realms, in part because we have the ability to define the physical, logical, and ethical boundaries of these systems, because the way that they model information is in an explicit human readable format. They're extremely energy efficient, and they are able to learn and adapt as complex systems grow at different scales. They're able to work together at scale. So they can apply to any application, device, environment, and enable hyper-personalized and hyper-customized solutions. And so while today's AI sort of systems learn on public, historical data, agents can learn from real-world sensory information in real time. But this also allows us to permission what access to data or what actions they can take in the physical world. And so this enables them to learn how to align with us, but also gives us the guardrails to enable, to ensure those alignments occur. And if your agent isn't smart enough, it doesn't know something, it actually can connect with other agents and download what it needs to learn from another agent, because it's in this explicit sort of network. Now, I want you to think about the difference between those computers of the 70s and the microprocessor moment, where everyone gets a computer. And then I want you to think about, instead of tethering to one portal on the internet like AOL, I want you to imagine this is a network of billions of agents operating in every IoT device, every computer, right, using this algorithm of natural intelligence that turns into these sort of collective intelligence frameworks that we talk about, that make up the nested architecture of intelligence that leads to something like you at planet scale. But because they can share this explicit information and learning, they can actually self-improve and improve each other in the same way that we're doing this today, where we all get to learn a little bit from each other and over generations compound. Now, I want you to now assume that that rate happens at 100,000 times the speed. And this is the key to solving the hypercrisis, right? Our individual and collective intelligence now could grow at exponential rates, right? And we do appear to need it because we're fast approaching an inflection point in the evolution of life. And we need the technology of nature and humanity to move beyond the hypercrisis to beyond the sort of intelligence ceiling. And so this requires us to move beyond this machine myth of superintelligence, monolithic superintelligence, to something greater. And so we call this hyperintelligence. Hyperintelligence is not superintelligence, it's shared intelligence supercharged. Collective network of intelligence of billions of software agents embedded into devices and spaces that we operate in, enabling people, places, and things to get smarter, to operate at hyper speeds and hyperscales. So I want you to imagine a world where hyperintelligence gives us a kind of planetary MRI, right? The Internet of Things and sensors giving us real-time sensory information, what's going on at any scale. A societal simulation engine and an autonomous GPS all in one. There's no alignment problem now. There's no arms race because there's no central race for a single AI to control everything. There's no one controls the web. No one controls the hyper-intelligent network, right? There's No accelerationist versus decelerationist. Go faster, go slower. Why? Because as a network grows smarter, it actually becomes safer and more sustainable. This is the whole point of decentralization. So this enables us to tell ourselves a new story, right? A more hopeful story about the future that will produce a smarter, safer, and more sustainable world where our collective imagination and shared intelligence become aligned with the innate wisdom of nature, right? So what I'm proposing is that we have to think differently about these systems. We have to move beyond this notion of AI and that its ultimate outcome is this sort of static, monolithic, super intelligent machine to a more evolved form of intelligence based on nature's blueprint that's distributed, that's adaptive, that's collective, that seeks balance and homeostasis. And so naturalizing our technology through the application of these natural principles, I believe, is the key to aligning us and our societal systems with the natural order, enabling all things to adapt and move with the rhythms of life. And so I'm proposing that we stop applying industrial age thinking and enter an age of imagination where the ability to create our future is not confined to the limitations of our bodies, our minds, or even our technology, but by what we're willing to imagine. Thank you.
Thank you so much, Gabriel. That was fascinating. I'm pretty sure there's so many questions about this. One of the questions that I'm thinking of is how do you, what kind of machine, or how does a machine that is hyper intelligent look like? How do you create something like that? Or is it still a computer? How do you imagine it?
Yeah, so there is no the machine, right? In the way that there is, it's a bit like saying the World Wide Web is a machine or the internet is a machine. It is, but it's made up of many, many, many other machines. It's made up of information, but it's human information. It's encoded in ones and zeros, but the meaning is interpreted by us. So if you kind of just look at this as the next version of the web, where every device could be encoded with a kind of software, where the software is running a sort of algorithm that doesn't learn from millions of examples of pattern matching data, but is able to learn in real time and able to learn to become a little expert. It's not about AGI or general intelligence. It's about little specialists. Every part of your body does something as a specialist, but then collectively, these things can work together at different scales. And so there is no the machine anymore. It's the kind of ecosystem of intelligences, working biological and non-biological, if you will. But where the underlying, I would say, to be perfectly honest, physics of sentience is the same. The underlying thermodynamic constraints are the same. And as a result, you get systems that will seek homeostatic, what's called the homeostatic objective function, right? Instead of a sort of human design function, which we have for AIs, which a lot of the existential concerns we have for AI, or a lot of their errors have to do with us saying, here's the sort of Pavlovian problem. Here's the biscuit if you do the thing, but it turns out that they'll do the thing in the wrong way. And because they're black boxes, we can't tell. And what you want is the thing to have its own actual impulse to try to find some sort of balance or homeostasis with other things around it. So you're not stuck in these sort of what's often called, the paperclip problem. So this gives us an alternative approach to that starts from first principles, that comes out of neuroscience and biophysics, and then not just trying to reverse engineer a brain in a box and then all the problems that have come with that.
Thank you. Any other questions?
Yeah.
Yeah, go ahead, James.
What's the political economy of all this? I mean, it sounds dramatically interesting and at a theoretical level, but you have some very powerful folks in Silicon Valley who are heavily invested in kind of the current trajectory. What do they have to say about this vision? And does it threaten them fundamentally? Are they likely to have to sell you the power, the computing power? This is a very radical.
You don't need the power.
Have you actually done the business case, the business model, where you say, here's the impact on the industry of our alternative?
If we're correct, this will destroy the AI industry as we know it. You don't need $100 billion data centers. You don't need supercomputers. You don't need GPUs. It'll run on a laptop. It'll run on your phone. It'll run on a camera. This is not theoretical. We've tested all this. So
that's what we need. That's what I think we need. That is
James,
there.
this is the personal computing revolution.
Yeah.
Again, it's the same. We've all just gone through this twice in the last 40 years.
Is there a white paper that lays this out? In
many? Yes, several. Yeah. So back in 2022, we put out a paper with our team called "Designing Ecosystems of Intelligence from First Principles." I'm happy to connect with you guys and show. There's like we have we've collaborated on 100 papers in the last year alone, but there are several recent ones that also show exactly the technical functions of how this works. It doesn't use neural nets. It doesn't use any of the methods or tools. This is kind of, again, a bit like very paradigm shifting in the same way that an electric vehicle is very different from a combustion engine, right? And what these guys are doing now is just playing a game of fuel injection optimization. Oh, look, 38 miles to the gallon. Now we can get 41. It's diminishing returns, and they have to pay 10x every time to get like 1 or 2% gains. And so the party's actually already over. There's an Apple paper that just came out this month. There's a Wired article about it that demonstrates that these LLMs, even the latest versions, really struggle at the kind of causal understanding of the world, which they're trying to learn from correlational patterns. But you want systems that can learn causal relationships from first principles, from the ground up. Little scientists, little detectives that actually learn these architectures, the cause and effect. And that's if you go look up this GSM 8K paper from Apple, who just pulled out of the OpenAI fundraising, I believe what was the old saying? The AI industry has already jumped the shark. We're going to probably see another model. I'm sure it'll be impressive for a few months, but they're not going to get to something that exceeds much of what human knowledge is, because it's just learning off the exhaust of human information. I believe we need something that go beyond that.
You're talking about 7 firms that are, as of yesterday, were worth $16.7 trillion market cap. So you're implying that we're sitting on a huge bubble.
Do you remember when AOL bought Time Warner?
Yes, exactly.
Remember when Nokia was selling 1 billion phones a year in 2006, and then 2007?
So the good news is we're about to see an economic collapse.
I mean, I think they'll pivot. It's not going to fall off the cliff, because there is utility in these systems, but there isn't a business there. I mean, there's no profitability in an LLM or generative AI. They're really interesting for content. And I actually think there's a road to hoe there that is content, but everything around real world automation it's a non-starter. And deep learning as an architecture, I mean, the industry spent $200 billion for autonomous cars, and we still can't. You still have Waymo stopping in the middle of the street last month because someone's wearing a stop sign on their t-shirt standing on the side of the road. So this lack of coherent understanding of the causal functions of the world is, in my opinion, and in our opinion, a minefield. It doesn't even matter if they get to 99% accuracy, because they're unreliably unreliable. You don't know where that 1%, which has been broken glass, is spread throughout the whole 99%. So if they understood causal relationships, then you could have some more trust around these systems, and maybe they'll find some multi-billion-dollar way to do that. But maybe we don't, like, we still have supercomputers and people use them, but most of the time we don't use them. So it's not to say that everything goes away, but I don't think this is not the current path does not look like the future of what we're looking for. And then when we talk about governance and regulation and alignment, it's a bit like trying to solve a set of problems related to mobile phones, right? In 2006, we need to be looking to where the technology goes, both from a perspective of what will actually work, and then why not build systems that self-align, and then just build the guardrails.
Great presentation and a great lead setup for our next panel. But Thomas, you had a...
Yeah, I just wanted to see whether you can give examples of tasks where the two kinds of intelligence could be made to compete against each other, where we could really try out how the two systems work and which one works better.
So there are all kinds of practical tasks. I could share those. What the industry kind of looks at overall are these benchmarks, and so you have AlphaGo, which beat Lee Sedol at Go in 2016, kind of launched the modern wave of deep learning and AI. AlphaZero came out a year later in 2017 and beat that. That was a deep reinforcement learning model. The industry after that said, great, we can show that we can throw enough compute and data at a system to where it can beat human capabilities I would argue it's cheating, but fine. You've done enough compute at it, and you solved that. So they said, well, what's beyond board games? And they moved to Atari. It should learn how to play video games in real time, adapt in real time, and be able to play this diversity of different games. So something called the Atari 100K test. And that Atari 100K test is what was created. Alpha zeros turned into what's called efficient zero. It learns in about 2 hours to play things like Pong. But it turns out these are quite complex because you have to be able to go from pixels to abstractions and understand how objects are moving in space and time. We expect the next 90 days to demonstrate our ability to beat AlphaZero, arguably the world's top multi-billion-dollar underlying sort of model, deep reinforcement learning model, using not with 100,000 samples in 2 hours, but in 12 minutes, not with 4 NVIDIA A100 GPUs, but on a laptop, and with a model that uses 90% less data, and do it in 12 minutes, not 2 hours, and do it in with a model that's hundreds or thousands of times smaller. We already did this test and shared it publicly about 4 months ago, just with Pong, and now we're going to do the whole series. After that, we believe that is the sort of least it all moment all over again. But here now is a better, cheaper, faster, safer. And by the way, you can see what's happening inside the model. It's explicit. And because it has confidence scores on all of its decisions, because it's quantifying uncertainty, we have a way of having an explainable model that's no longer a black box. So there are practical examples, but I think from an industry-specific lens, we think we're at an inflection point between now and the end of January, we expect to be able to publicly share that paper. And if we're correct, we have tons of evidence internally that we believe we are. We think that is a moment that is noteworthy sort of globally. Use cases, happy to share more, but I don't want to take any more time.
Thank you. Terrific. Thank you.